review for the final dramatic echo. We're gonna start off with number 6, okay? Because like I said, this year there's a little bit less stuff on it. This year specifically, maybe not in the future. But we're starting off with number 6, okay? Some of these have already written the numbers on the board. Other ones you can see what's on the example for the entire semester review. We're going to go over everything, all in one. It says state the domain and range for this function. Okay, so it's got your graph right here, and then it has a swooshity, wait, like this. Okay, at 5. Okay, it's called a swooshity. No. So what's happening is this line is approaching 5, but it's going to like an airplane about to crash. Pull up, and it's never going to touch 5. It's called an asymptote. It's something we didn't get into as much this year, but it's infinitely going to get really close to 5, but never cross 5. So if I'm talking about the domain, what's the farthest left value?
Infinity.
Negative infinity, right? Okay, and the farthest right value? Infinity, right? So there you go, that's your domain, okay? So you can also call that all real numbers, okay? The range, the lowest value is 5. But does it ever cross 5 based on the thing I just talked about? No, it's going to get really close to 5, but it does not include 5, hence the bracket or parenthesis instead of a bracket. And then the highest value, infinity and beyond. Okay, cool. Now, if you want to express that with a less than, greater than, all that stuff, okay, you would have the same thing. I'd have 5 over here. Remember this whole situation with the numbers? And then you have your y in the middle. Remember that whole thing with the less than, greater than signs?
Yeah.
The parentheses match up with this, right? So there would not be a line underneath because it does not equal that. And then you just erase the infinity sign. Where am I? You just erase the infinity sign, and there you go. Now, if that looks weird and you have an answer option that doesn't have 5 is less than y, then you would write this. Y is greater than 5. Hopefully that didn't just blow your mind, but it's the same dang thing, right? Y is greater than 5, and it makes sense that y is greater than 5, because here's 5, and the whole graph is greater than 5. Okay, cool. All right. Number 7 has the same thing. It shows you 4 different graphs and says, which of these graphs have a range, I'm thinking up and down, a range of all real numbers. This graph right here does not have a range of all real numbers because it flattens out right there, so that's not it. If you look at the C option, this one does not have a range of all real numbers because it goes from here up, right? So that doesn't count. And then I got, what is the other one that does not? D is absolute value. Again, it starts from here and goes all the way up, so that doesn't count. The only one that has a range of everything, meaning all the way down, all the way up, is
B.
Yeah, that one, because it goes all the way down and all the way up. You need to have a good foundational understanding of absolute value, domain and range to be able to knock out those questions. Cool. Next one, skipping around here. Don't worry about this. Number 8. Number 8 was enough for me to, it's a little word problem. So you don't need to see the table necessarily. A gardening service costs $20 to mow a lawn. I just started getting my lawn paid. It's amazing. Man, it's a rough thing to do. And $3 for each individual flower that you want to plant. Okay, so would this be a linear relationship? Write an equation for the cost and stuff. Okay, so gardening service costs $20 to mow a lawn. It's just straight up $20. They're mowing the lawn. It's $20. Cool. And $3 for each flower that they plant. Right?
Okay.
So that's your equation. What would the equation be for that? So the cost that it would cost me is $3 per flower that I want to plant it, and they're paying and they're mowing the lawn. Right? Done. That's a very simple linear equation based on words and stuff. I wanted to make sure to address that though. That's number 8. Number 8. Okay. So again, that's per that every single time goes with the 3. The lawnmower is just one-time thing, so there's no variable attached to it, okay? There's that. Skipping 9, 10, 11, 12. Moving on through. I'm highlighting the most important parts here. Number 13, okay? Which brings us to our first table up here that I have pre-written for you guys because I'm prepared. It says distance traveled, marathon shown below, write a function to represent the data. Did they tell us that this function is linear, quadratic, cubic, or exponential?
No.
No. You should be able to find that out though, which is the biggest single theme of this whole final is, cue the sound effects, is this concept of being able to know what's going on. So I'm gonna start doing my differences. Here we go. 6 to 12, I'm adding 6. 12 to 18, I'm adding 6. 18 to 24, I'm adding, I'm just kidding. That's a
There's 30.
666 joke. Too soon. All right. Oh my God. Actually, I'm gonna add in the fifth one right here, which is
Yeah.
30. So I add it. So now it's good.
Now
good
it's not bad
Okay.
anymore.
Whew. All right. Anyway, is this linear, quadratic, exponential, cubic? What is this? Linear. That's a huge thing. I'll write it down here in just a second. But in fact, I'll do it right now. If it's a first layer difference, that's linear. This would probably be a great thing to write down, to have for the test. Second layer difference is quadratic. Third layer difference is cubic. Multiplying, I can't spell multiply, multiplying is exponential. And deal, okay, cool. Okay, that is how you figure this thing out, okay? That's gonna be huge for all the rest of these things we're doing here in a second. Single biggest thing probably. All right. So I've identified that it's linear, which makes me think of, and you'll have your formula chart as well to use, but y equals dx plus a sub 0. If you have so much rust in your brain that you're like, oh my God, wow, that was a long time ago. Yes, there it is. There it is.
Wow.
Okay. The difference plus a sub 0,
Whoa.
okay? So I'm going to go backwards by 6. 6 minus 6 is 0.
Oh.
So y equals the difference in x plus a sub 0. That's it. Y equals 6x. That's the function that represents your data.
Fantastic.
And it's linear. That's also an important thing. I have to make that note too. Okay. Nice. Moving on. 16. Some more domain and range stuff. Okay. Again, I just want to say that like the first one on 16, I'll just hold it right here while I talk about it. The first one on 16, that is domain and range, all real numbers. It's going left and right for forever. It's going up and down for forever. Okay. The next one, it's the same thing we just talked about. We're not going to talk about that one. It's going left and right. Domain is all real numbers, but it's swooping down and stopping at -1, right? Yeah. So -1, yep. And then that one right there. Whoa, hey. That one right there. The domain, we'll do that one. The graph, it's at 2 right here, and it's just doing this whole thing. Swoosh. Okay. The domain, all real numbers. The arrow goes forever this way and forever that way, all real numbers, okay? But the range is from 0 to infinity, right? So 0 to infinity. And it does include the 0, okay? It does include the 0. So if you want to do inequalities, because you're going to need to know both of those, we're talking about range here. Yep, we're talking about range. So I have y in the middle with my little sandwiches, right? 0 and infinity. This is always good, but this gets an underneath sign because it's a bracket. It does include 0. 0 is there. So then when I do my erase trick, my answer would be y is greater than or equal to 0. Make sure the alligator is always eating the same thing if you do flip something like that, okay? But again, this is also the same thing as this. It's just different languages to say the same dang thing, okay? And then for the question on 16, it says the domain of the functions, of all the functions, is negative infinity to positive infinity. That is true. All three of those graphs go forever to left and right. Next one, all three functions have an x-intercept. If you look at them, do they all have an x-intercept? Ooh, interesting. Interesting. So we just said that it goes forever left and right, right? We're talking, x-intercept, yeah, okay. They all do have an x-intercept. You can actually see them. There's, they cross, it crosses, and this one, we said that 0 is included in there, right? Which is on the x-axis. It does touch it or intersect it right there. So yes, they do all have an x-intercept. My question to you guys, do they all have a y-intercept?
No.
the first one, if we're going from left to right here, the first one does obviously have a y-intercept, yeah. The second one does obviously have a y-intercept here, yeah. The third one does have a y-intercept. But can you see it on the current picture that they've shown you?
No, because eventually.
No, but what's right next to that y-intercept? What is right next to it? An arrow that goes forever in both directions. So eventually, will it cross the y? Yeah, it will. So they do all have y-intercepts. You can't literally see it, but your imagination with arrows can make that happen. Okay, cool. C, the range of all of these functions. The range of all of these functions is negative infinity, positive infinity. That is not true, because we just talked about that. This first one is all real. This one's not, because it does the swoop down stop. And this one's definitely not, because it only goes from here up, which is not down for forever. So no, that is C is the correct answer for number 16. Okay. I know I could have answered that much quicker, but I wanted to make sure we fully understand domain and range for that whole situation. Okay. Number 18 now, going back here. What's the B value? Uh-oh. We have y equals ax squared plus bx plus c. This was the second unit test we took. Okay, so I need to know the b value. Again, you'll have all your answer, you'll have all your formula charts. It's up here on the board, but you should have it and it should be attached and all that good stuff. So, the differences here, we go, first one I have 6. 1 to 11 is by going by 10. 11 to 25 is 14. And then we have 18. Is it linear?
No.
Well, obviously it's not, because it's x squared down here, but yes, it's a good thing to notice that. Then it's going by 4, going by 4, going by 4. Great. So now, A equals the second layer difference divided by 2. I didn't just make that up. That's part of the formula. So it is going to be 4 divided by 2, so A is 2. Got it. Or you can think of it as half of the second difference. Divided by 2 is half. Okay, cool. Then my B value is my first layer difference. My first difference minus A. I know what A is, but what's my first difference? Okay, first difference between 0 and 1. Remember that whole thing? It's this. Okay? Your first difference, that was the biggest curveball that I warned you guys about. Your first difference is the difference between 0 and 1, the first of all of the first layer differences. The first difference. We talked about that too. 6 minus A. A is 2, so B is 4. Oh, so B is 4. That's the answer. That's all they asked for. That's all they asked for. Is B 4.
I
If
get
you
it.
knew that before, Coach B.
Bro, what?
What? All right, cool. Next level jokes. Then we got,
My brain.
moving on, flipping it over, moving on. Number 23. Yeah.
Are we able to use this review?
Wait, what?
Yes. Yes.
It's
Okay.
open now.
23.
23. Hold on.
Home stretch now. Is 23 up there? What's going on? Oh, yeah, 23. Find the finite differences of the given sequence. Bang, there's the sequence. 18, 29, 40, 51, all that good stuff. The difference between each one is constantly adding 11. How thoughtful that they asked us the difference so that we instantly know it's adding by something, and then it just worked, right? That's like the first worksheet we ever did. That's the concept right there. Easy points right there. Don't miss that one. Then the 24 is just as easy. It says, what's the common ratio? Oh, that's multiplying. So then I would do 24 to find out. Dear Lord, please remember this. Please do not do 6 divided by 42, enter, and then type that number in. That is not it.
42
That is not it. It's asking you, what is it multiplying by? So don't divide forwards to 5. So anyway, if you want to know what 6 times what is 42, then therefore I would go backwards and do 42 divided by 6. Okay? You get 7. Okay? Now, once I did that and got 7, I probably, now if this was a worksheet or something, sure, 7, cool, move to the next one, okay? But if it's the test or the final, take another extra second to do it just one more time. 249 divided by 42 is also 7. Okay, I feel good now, I can choose 7. Okay, so just make sure you get it right, just so they're not tricking you. Especially if the answer option D is none of, it's not one or whatever. Anyway, 25, right there, 25. Look at the table. What type of function does it represent? Again, this is the number one thing worth the most amount of points on the final. So I'm going, here we go. We got 18 on this first one. We got 30 on the next one. And we got 42 on this one. So out of all these things we talked about, what do we now know that it's not?
Linear.
It is not linear. It could be quadratic, it could be cubic, and it could be exponential. I haven't even checked for exponential, because what do I have to check for exponential? Multiplying, right? Now, looking at this, it's not, because -2 to 16 it's not going to be. But again, keep in mind, multiplying is a different one. This is a little different one. Okay, so I do it again, and I got 12 and 12. Oh my goodness. So what is it?
It's 12. Oh, it's quadratic.
Quadratic, because of the second layer. First layer is linear, second layer is quadratic. So it would be a quadratic, done. Okay, number 26. 26, this is one I need y'all's math numbers on. Here we go. 8 to 40, we're going up by 32. 40 to 108,
68.
68, great. 108 to 224, you lost me.
116.
What?
116.
116, thank you. Then 400,
176.
176, great. So is it linear?
No.
Definitely not. All right, so then I do it again. I got what?
Wait.
36?
Yeah.
And then this is
Wait.
8,
48.
12, 6. This is where y'all's calculators.
I just said 48.
48, then what?
Wait.
126, and then I'm already seeing the pattern here though. You can tell already, is it
60.
gonna be quadratic?
No.
No, it's not. So we have 60. Oh, that was easy. I should have been able to do that.
Yeah, come on.
So 12 and then 12. Okay, cool. It's not linear. It's not quadratic.
It's cubic.
It's cubic. Perfect example. Okay. Next one is also a perfect example. And if you see the pattern here, we did a linear, we did a quadratic, we did a cubic.
It's
Spoiler alert, 27. If you look at this, 6 times 2 is 12. 12 times 2 is 24.
Wow.
24 times 2 is 48. You should be able to identify doubling pretty easily. But let's say worst case scenario. So this is exponential. Spoiler, I just gave you the answer.
Wow.
It's exponential, but worst case scenario, you start doing all this stuff, right? And you get all these numbers, and you do it again, and you get all these numbers, and you do it again, and you get all these numbers. Oh, it's not linear, it's not quadratic, it's not cubic. Oh crap! Maybe I should check for exponential. So try and look out for exponential. See if you can catch it. Save yourself from doing all that work. But that's a good last resort as well. Okay, so 27 done. 28. Look at the table. What type of function does it represent? Okay, quadratic, all that good stuff. So 28, we're doing the same thing. Here we go. -2 to 10, we got 12. Then we got 20. Then we got 28. And then I already am noticing a pattern here of 8. And I don't even need to know the next one. This is quadratic. Bang. Okay. But then let me just, for completion purposes, that's going to be a 36. And that's an, oh my gosh, okay, cool. So quadratic, cool, done. All right, now, for the rest of all of these, it's saying, which of the following tables is linear? How do you know? Just like we've talked about,
Yeah.
it's the first layer. So you would do the same thing we just did for both tables. Oh my God, it's so much work. Oh, it's the final. You do this, all that for both tables. One of them is going to be a linear first layer difference. The other one's not. The next one, you have a quadratic function. How do you know it's the second layer? And then so on and so on. Backside. Blah, 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 blah. Cubic, same thing. Blah, 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 blah. Exponential, same thing. Okay? And then the last one, look at this table. What type of function represents? Cubic, exponential, justify your answer. I kind of just want to do this now. I did not have this written down, but I want to give some closure to that final question. 0, 1, 2, 3, 5, 7, 15, 35. I'm just gonna rock with these ones right here. I can guarantee it's not exponential. In general, I check for exponential first. 5 times something is 7,
No.
but 7 times 2 is 14, so that's more than times 2. So it's 5 times 2 is over. So see how it's not, it wouldn't work. Anyway, that's just my little thought there. So I'm already crossing off exponential. So anyway, we got 2, then we got 7, 8, then we got, 20?
Yeah.
20. So that's going to be 6, and then that's going to be 12. So I'm going to have to keep going to that 4th layer here with a 73, which means 35, 36, 38, which means 18. Oh my gosh, which means 6, which means 6. Hey, 3rd layer difference, cubic. Okay, there's that whole thing. All right, I'm glad I did that one because cubics are going to be the most difficult ones, or that take the most work to do. And if you didn't have the formula chart at home, there it is.
Oh.
But there's also a better formula chart that you'll have as well that has the formulas a little bit more used to how you're just used to seeing them. So good luck out there.